Hi teacher, I'm Dũng and I'm currently a teammate with Trí Nhân. I would like to represent my team to say thank you to you for teaching us and giving us a lot of novel knowledge. Thanks to that, throughout the course, we've realized that linear algebra has a lot of application in our lives. It's an integral part in face identification or making an apps like multisms by using magic algorithm, and the latter is what we aimed for. But first we need to find the information, and I was in charge of this section. I mean, I, I was in charge of the idea arrangement. I need to find the information and arrange it so that Bill will put it on the PowerPoint and G will present and clearly explain what R means.
Hello teacher, my name is Thiện Nhân and I am a PowerPoint designer for our team. And after we agree with the information in our project, I upload those content to PowerPoint and Chi will be the main person who have the presentation about it. For me, I will show you why we choose this application. Well, while we were designing the electrical circuit, which is integral in our major, we wonder that how can from the input data, the app can calculate the other material like voltage. Well, it turns out that all the input data like the resistor and the input voltage was saved as a matrix, and this app use those matrix to calculate all the other values. Well, it was surprised at first, but that's how most of the app calculation works. And not only the electrical circuit, but the flow traffic, and most of the MATLAB were used based on this method. And we will explain it more clearly later.
Hello, teacher. My name is Trí, and today, on behalf of our team, I will present about our topic linear algebra in network analysis. And my name is Trí, and I am the presenter. And our mate are Ngô Tiến Dũng. He arranged the idea. And the last one is Võ Thị Nhân. He is the PowerPoint making. Is the PowerPoint maker. So first, we have to determine what is matrix. Matrix is a rectangular or square table of numbers, characters arranged in rows and columns. As you see, we have the form of matrix, which M is the number of columns and N is the number of rows. For example, we have matrix A 3 times 2. This means that 3 is the number of column and 2 is the number of row. So next, we have to determine what is the echelon form. Uh, the echelon form is the form that all the rows consisting of only number zeros are at the bottom, as you see, and the leading coefficient or the pivot of non-zero number is always that the higher is always to the left of the lower. As you see, the number one, which is the pivot of the row one, and it's to the left of the number one of the row two. So what is reduced to echelon form? Reduced to echelon form, which means that we reduce to from the normal matrix to the echelon form. As you see to the left, from the left to the right, we reduce first at row 2, we put, we time, we let the row 1 time minus 3 over 2 plus row 2, and we have the new row 2, and with row 3 we let row 1 time minus 2, and then we plus row 2, so we have the new row 3. So finally we have row 3 equal to minus 3 times row 2 plus row 3. So we have the echelon form, uh, and we can see this is the uh, this is the step step 1, and then we go to the next part, the application of linear algebra. Uh, in real life, we have a lot of application of linear algebra, but because the time is limited, so now we will just introduce about the application of linear algebra in network analysis. Matrix and reducing to echelon form can be used to determine the flow of water, the flow of traffic, or the current in electric circuit, or we simply know as the network analysis. And the main idea of the network analysis is that at one node, uh, the flow in equal to flow out. As we can see in the picture, uh, I1 plus I2, which is the flow in, is equal to I3 plus I4, which are the flow out. So we come to the first problem, find the traffic flow. As we can see in the picture, uh, there is a closed path, uh, the closed shape. We have five nodes, not one, two, three, four, and five, and we have three flow that are known and five flow unknown. So our mission is to find unknown flow. So we apply the main idea of the traffic flow. At node A, we have x1 plus x2 equal to 20, uh, 20 and 20 is the flow in, and x1 with x2 is already flow out, and similar with uh, for node B, C, and D. Node B, x3 minus x2 is equal to minus 20, and node C, x2 plus x3 is equal to 20, and at node D, x1 minus x5 is equal to minus 10, and at node D, minus 4 minus x4 plus x5 is equal to minus 10. So when we have the system of linear system of equation, then we reduce to the echelon form. As you see on the second picture, we have the we write the linear equation as the matrix. Then we reduce to the echelon form as we see in the picture 3. So we have the solution. So we have finally we have the solution. X1 minus x5 is equal to 10. X2 plus x5 is equal to 30. X3 minus x5 is equal to 10. X4 minus x5 is equal to 10. And we let x5 is equal to t, and t is a real number. And then we have x1 is equal to t minus 10, x2 is equal to minus t plus 30, x3 is equal to t minus 10, x4 is equal to t plus 10 and x5 is equal to t. So as we see, uh, we can we can control the flow in, we can control the traffic flow based on the variable t. We can change the variable of t from 0 to infinite so that uh, this application can be used to control not only the traffic flow but also the water flow at one time. So we come to the next problem, electrical circuit analysis. And the main idea here is based on the Kirchhoff's law. The Kirchhoff's current law uh, said that at one knot, the current in is equal to the current out. And the Kirchhoff's voltage law, the sum of V equal to I times R. V is the voltage, I is the current, and R is the resistance. In one loop is equal to 0. And here we can see at node 1, I1 plus I3, which is the flow in, is equal to I2, and this is the current law of Kirchhoff. And in loop 1, as you can see, minus 7 plus minus 7 is the voltage source plus 3 times I1 plus 2 times I2 is equal to 0. You see the voltage law in ellipse 3, ellipse 2, 2 times I2 plus 4 times I3 plus 8 is equal to 0, and this is the voltage law. So we can write a system of the linear equations and reduce to echelon form. As you can see, we write the linear equations as a matrix. As you can see in the first picture, then we reduce to the echelon form, as you can see in the second picture, which we can determine the value of three current. I1 is equal to 1 ampere, I2 is equal to 2 ampere, and I3 is equal to 1 ampere. So when we determine the three currents, we can easily calculate the voltage, uh, three resistance, 1, 2, 3, respectively. So we have at R1, R1 is equal to V1 divided by I1. So this is 3 volt, and R2, uh, sorry, uh, V1 is equal to I1 times R1. So we have 3 volt. I2 is equal to uh, V2 is equal to I2 times R2 is equal to 4 volt, and R3, and at R3 we have V3 is equal to I3 times R3. It is 4 volt. So overall, we can control the flow of the road users in 5 different ranges via variable t, as we see in the problem 1. And similarly, we can apply the same method to find the flow of water. And besides, it is useful for engineers to analyze the network, especially the uh, electric, electrical and electronic engineer as us. We are the electrical engineer in the future, so we have to use the application of linear algebra a lot like the electric circuit analysis, as we have told before. So hopefully, uh, after this presentation, we have more chance to find more interesting things about linear algebra in many different in many different fields in real life. And thank you, teacher, for listening, and uh, thanks for teaching us in semester 213.